All right, morning everyone. Last one. Okay, first announcement is, yep, today we'll have a drop-in 1 till 2 as we do every time after the lecture. But after today, every drop-in's just 12 to 1, every day up until including the exam date. So, weekdays, obviously. We don't come in weekends. So, every day 12 to 1 up including the day of exams. B2 redemptions due, we're still sneaking in B1s as well, I admit, so just get your B redemptions in, they're well worth doing. Note that next week's tute only, so it's our last lecture, yep, but next week we've still got a tute, okay? But that's all we have in maths next week is tutes, so it'll be a small quiz on this week's content, so you will have done a little 10-minute quiz on everything we did, and the rest of it's revision, big revision Kahoot, and a revision handout. So that's next week. So remember, yes, we've still got tutes next week. More redemptions due. And just say, getting your B redemptions by the end of exam week 2. Okay? So that's fine. So even if you're doing your redemptions throughout the exam revision period, throughout the exam period, that's fine. You're still learning from it. So Shafan, there's still time for a few more redemptions. Okay? Past papers. This is the last time all of us together. So just saying that any past papers that you haven't gotten back, including like next week, we'll do a quiz, but we won't have a tute to give it back to you. I'll just take it all to the office. MCLG 49, the new step glass window office. From exam week 1 on the Monday, so if you want to grab them, if you want to do redemptions, or if you just want to grab them for study purposes, they'll all be at that window. And if you're picking them up off them, just bring your student ID. They just want to see your ID to prove it's you, not someone else trying to nick your past quizzes, as we'd all want. The surveys are still in your email, so if you can do those or both preferably, the feedback on my teaching or the feedback on course, it'd be awesome if you could do any of that. We really value it. The final exam content, well, there's the summary. There's the A lectures, all got 5 marks per question. So there's 11 questions in the exam. The first 6 questions are just worth 5 marks each, and that's A1 through to A6. Can we please, especially this bit, have a listen instead of a chat? Okay, this is pretty good stuff to know there's only 5 marks on each of the A lectures. So there's 30 marks in total over 90, 1/3 of the final exam. Whoa, I don't think centre projector's cooling down. Why? Don't. Light on. But I didn't touch it until then. Okay. System's turning off. Please wait. There's no abort. Okay, fine. We're going to lose that for a sec. And probably the lights. So your mid-semester exam, 1/3 of the final paper. If you just study that, that's fantastic. Okay? I already admit that mid-semester exam content covers what we want for that 1/3 of the paper. As for the next 60 marks out of 90, 2/3 of paper, yeah, it's all B stuff, 12 marks per thing. Predictable as anything. I'll put up a revision paper this afternoon. I'm not sure if I'll get the video done today, but I will definitely get a video solution up of just me doing the paper, like a mini lecture summary or a summary of the last semester, okay? What was the vote? The vote in here was 2 projectors or 1 projector? 2 screens or 1? 2 screens? 1 screen? Just what? I get the option now whether to pick 2 screens or 1. Okay, 1 had it. So it'll turn itself again. What were we talking about? Final exam revision paper up the Savo. Yep, okay. So What other reminders have I got here? Revision paper coming, yep. All right, time for the lecture. Oh, that's pretty quick. Okay, so this week's lecture is probably unique stuff, okay? It's not earth-shattering, as in a lot of these you'll go, yeah, okay, that's pretty logical. And the rest of it is going to be about two main buttons on the calculator. Buttons you probably haven't used before. I'm not sure of everything about the syllabus. Has anyone done permutations and combinations before? Is that ringing a bell? We'll see how it goes. Anyway, firstly, last week when we were calculating probabilities, the number of favourable outcomes in the event and the total number of outcomes have to be counted. We said that last week when rolling the die. How many outcomes favour the event? Maybe it's just roll of 3, 1. How many events is in the total outcomes? 6. Okay. But note that sometimes these numbers can be quite large, and that's what this week's about. We're still probability, clearly, but we want to work out for some things how many different ways can something happen, and it's not just as simple as rolling a die. So we want to be able to work some stuff out, and the first concept is really very simple, and it's again locking in. I was saying this last week, and is a times. This first principle says that if an operation A can be formed in m ways and an operation B can be formed in n ways, then if you do A and then B, the number of outcomes is m times n. Sounds horrendous, but it's just saying, how many ways can I do this? Maybe 5 times. Then I'm going to do something else. I've got 4 options. 5 by 4 tells me there's 20 different things that could happen. Let's look at an example of that. If we've got, they're trivial examples. But you can see, hopefully, an application. If I have 3 shirts and 4 pairs of trousers to choose from, how many different combinations, different outfits of shirt and trousers do I have? Well, I could wear shirt A, B or C of my 3 options, and trousers 1, 2, 3 or 4. And so if we drew the tree diagram, sure enough, we can see the 12 outcomes. What we want to do is avoid the tree diagram. We don't want to draw tree diagrams for some of these ones where lots of things are happening. We just want to trust the concept. If I had 3 options, then 4 options, 3 times 4, I would get 12 options if I drew a tree diagram. So hopefully, yeah, I would get those 12. As another example, all right, they've got entrees in this restaurant, a main course and a dessert. From the menu options given below, how many different 3-course meals are possible? Well, I've got 2 different options of entree. I've got 3 different options of mains and 2 different options of dessert. It is just good old 2 by 3 by 2. We don't have to draw the tree diagram. 2 by 3 by 2, there's 12 unique combos of 3 courses. Here's the tree diagram for it, but you can see if I've got 2 and each 2 breaks off into 3 separate options and each 3 separate options break off into 2 options. Again, 2 by 3 by 2. Hopefully I've convinced you that's got to be true, and let's not have to draw the tree diagram. So here's, and they get wordy, a basic pizza in some shop consists of 1 type of cheese, sauce and topping. So you choose a cheese, you choose a sauce, you choose a topping. What's the difference between a sauce and a topping? Topping's whatever, capsicum or something. If there are X types of cheese, Y sauces and Z toppings, how many varieties of basic pizza can be made? Just lock in. Already heard C. It's exactly right. It's just a multiplication. How many ways can I do this? And do this, and do this. X options, Y options, Z options, X, Y, Z. Perfect. Okay, if I throw a coin and a die into the air, remember singular of dice? How many unique outcomes are possible when they land? I could write them all out. I could get a head and a 6, a head and a 3, a tail and a 4, blah, blah, blah. But there are 2 options from the coin, 6 options from the die. 2 by 6 is 12. My tree diagram would have 12 arms at the end. So, point 1 made, hopefully. That's successive operations, it's an and all I could just have to do is multiply. The second principle is just the addition one, which still relates to last week. Last week I said, if I was talking about that coin and that die again, I'd say I've got to say what's the chance of getting a head and then a 6. A head is 1 in 2, a 6 is 1 in 6. Chance of getting that and that, I'd multiply them, and is a times. But if it was an or statement, what's the chance I could get a 2 or a 3 on rolling a die? Or was a plus. So the addition principle is, if one operation can be performed m ways, and a second mutually exclusive operation can be performed n ways, as in they can't both happen, it's like a 2 or a 3. It's just saying, just add them. It's just m plus n ways. So let's look at an example of that happening. Or is a plus. Same question from before, but how many different variations of 2 courses could I choose? So I don't have enough money to go for the 3 course. So maybe I could get a vegetable soup and a schnitzel, or an avocado salad and a burger, or maybe a burger and an ice cream, or a schnitzel and a cake. So there's more combos of just picking 2 of them. So what could I do? Well, here I've got to set up the number of 2 different course variations. I don't just say 2 plus 3 plus 2, I've got to think of the ways it can happen. I could get an entree and a main. Absolutely, I could do that. I could get an entree and a dessert and skip the main, or a main and a dessert. That's the only 3 things I could come up with. Okay, if I'm just picking 2 things out of those 3 options, that's it. But within each category, like how many ways can I choose an entree and a main? I've got 2 options in the entree, 3 options in the main. There must be 6 ways to do that. I could get an entree, 2 options, or dessert, 2 options. So if I'm getting that and that, it's a 2 times 2. There's 4 different entree dessert combos I could get. Soup, ice cream, salad, ice cream, soup, cake, salad, cake. There's my 4. Main and dessert. Well, 3 options are main, 2 for dessert. And what are ors? Ors are pluses. So we've got the 6 plus the 4 plus the 6. There are 16 different ways that can happen. So we just had to focus on, I could get this and this, that's a times. Or, I'm plussing, this and this. So you've got different segments of times, and you plus them up. It's exactly the same as if I did a tree diagram. Walking across the arms, I'd say that and that, I better times them. But that outcome or that outcome, I would add them. So same question with the pizzas. Okay, there's 3 different options, cheese, sauce or topping. But if I'm particularly poor, I could get this cheapskate pizza, which you only pick 2 of them. So there are 2 of these 3 things. And again, I'd have to say, okay, so I can get cheese and a sauce, or cheese and a topping, or sauce and a topping. They're the only 3 different combos I'm looking at. And each one has cheese and a sauce, I'd have XY options. Cheese and a topping, I'd have XZ options. And sauce and a topping, I'd have YZ. So again, we're not going to do these things algebraically, it's just a way to show it. As long as you can find the different options and add them together, we're gold. And a lot of this is heading for when we use this key on the calculator, it gets a lot nicer. The calculator is going to do most of our work. We've just got to work out the way to start the problem. So some of these questions will have repetition, some is without repetition. It's like last week we had with replacement or without replacement. It's the same concept. Either can I use that thing again, like if I took a card out, did I look at it and put it back? Or once it's out, was it out? Same thing if I'm trying to say an example, like 4-digit PIN numbers are formed with the digits 6, 7, 8 and 9 in this example. And all numbers may be repeated. For whatever reason, we're only given the option of using 6, 7, 8 or 9. How many different PIN numbers are possible? Well, here's just me putting 4 numbers in a row and saying, these are my blanks. And if I'm only picking from 6, 7, 8 and 9, then I've got 4 options for what the first digit could be. Now, it says numbers may be repeated, so I've still got 4 options for the second. I've still got 4 options for the third. I've got 4 options for every single digit, if I can repeat. Because 6, 6, 6, 6 is an answer, so 6, 7, 8, 9, all of the above. And if I'm going to have that, and that, and that, and that, it's timesers. So how many different PIN numbers can I form in this way? 256 PIN numbers. Okay? So you can see there's lots of different combos, especially if we use all the digits. If the repetition was not allowed, and I said you can only use each digit once, then I've still got 4 options for what the first PIN number could be. But once I've used a number, I've only got 3 options. And then once I've used another, I've only got 2 options, and I've got no real decision for the last one. I've only got 1 digit left and 1 spot left. So if there's no repetition, 4 by 3 by 2 by 1, I've only got 24 different pins I can make. So here's our first thing that, we just decide in our question, how many blanks have I got? How many options have I got? And after I've used each option, is it still available? Or did the question say, that's it? This is a generalisation that, again, the algebraic generalisations may look hard, as long as we get the concept behind it. First, it's saying if a coin is tossed 8 times, the number of possible outcomes is k to the n, which is 2 to the 8, which is 256. All that's saying is let's just look at it one by one. There are 8 options here. There are 8 events. It's like me, I've got the habit, I know they're not good boxes, but I'm doing something 8 times. How many options have I got? How many outcomes for the first toss of the coin? There's 2 different things that could happen. What about the second toss? 2 things. Everywhere along here, I've got 2 options. And I'm going to do that, and that, and that, and that. So the answer is 2 by 2 by 2 by 2, 8 times. Shorthand. Okay, 2 to the 8 is exactly the same as what I've written in the boxes. So any time we've got something that's happening repeatedly, we don't want to write it all out. If I was rolling a die 12 times, I don't want to write 6 by 6 by 6 by 6, so on. I just want to write 6 to the 12. Okay, so the notation, the power notation is just for this sort of example. If a die is rolled 3 times and I need to know how many different possibilities, 6 options, 3 times, 6 by 6 by 6, 6 cubed. This is similar to the thing we did last week. Hence, in how many different ways could the 8 multiple choice questions in an EPMATH127 quiz be answered? Last week, it was straight to the probability. Our answer was, I had a 1 in 4 chance to get the first right, and 1 in chance for the second, and blah, blah, blah. And we got, with all 8 of them, we called the answer a quarter of the 8. This week, it's a bit nicer. We're not saying the probability yet, we're just saying how many different outcomes. There's 4 outcomes in question 1, 4 in question 2, 4 in question 3. It's 4 to the 8. It's nothing like this. It's not like once you've picked an A, you can't pick an A again. Apparently someone informed me the other day that I nearly only do B's and C's anyway. Apparently it was you, Zach, wasn't it? That I normally just do C's, and you guessed it and got it right? Yeah. So note that for this week's quiz. I don't know if I have or haven't. But anyway, 4 to the 8. That's it. Okay, if something happens many times, it's the number of options to the amount of times you do it. So here's some more examples like this. It's the exact sort of ones we do. And I still just like to see how many vacancies have I got and what possibilities have I got to fill it. If a license plate consists of 3 letters, all right, here's my 3 vacant letter spots, followed by 3 digits. All right, they can be letters and they can be digits. How many options have I got for the first letter on the number plate? Normal alphabet, 26. 26 options there that I could put in there. Does that reduce or stay? No, it stays, doesn't it? You can have repeat letters in number plate. We've got 26 options for all of them. Now for the number of digits. How many have we got? Yep, we got 10. It's easy to think 9, but remember, yeah, 0 is an option. We're a decimal system. We got 10 options. I forgot to get the calc out, going to need it for a few of these. So my 26 cubed, my 26 by 26 by 26 is a 17576. So if I multiply all of them, because I want that to happen and that, the 26 by 26 is 7576 by 10 by 10 by 10. So there's 17.5 million options. And we've gone through that. I don't know how many rotations we're on. I think we're probably on our 3rd lot of repeating number plates. I don't know, but also we've got the state definitions and all that. So we've got other variations in there which help give us a lot of combos. But that's how many are possible in that situation. What about if the number plate begins with the letters BMC, those initials, and you want to know how many different number plates are possible with the BMC start? Well, they're locked. BMC are locked in. I've got a number option, a number option, and a number option. How many BMC plates are there? Because there's 10 options of a digit here, 10 options of a digit here, 10 options here. Just a 10 by 10 by 10. There's 1,000 of these plates. Okay, they start with BMC 000, they end up at BMC 999. Yeah, okay, 1,000. What if we want to lock in the plate starting with A and ending with 7? All we do is go back to the original and say, well, the starting point is already an A. That's one option. But the missing things is the 2 more letters and 2 more digits, and then it finishes with a 7. Careful with that. I'm not saying multiply by 7. I'm just saying that spot's taken. by a 7. All I've got here is I've got a 26 by 26 by a 10 by 10. They're the only options I've got. 26 squared is a 676 times 10 by 10. So there's still 67,600 options there. Okay, so as long as we know how many letters or numbers we're dealing with and whether they're allowed to have repetition or not, these ones should go okay. This is where we'll get to the calculator soon and just say this overall concept, the majority of the lecture is just permutations versus combinations. A permutation is an ordered selection and a combination is an unordered selection. So it means like if I'm selecting 5 people out of this room to represent New Step on a committee, that wouldn't be ordered. Okay, you're just 5 people in a team. A team's not ordered, they're all equal members. It doesn't matter in which order I called out the names, if I called it out alphabetically or reverse alphabetically, it doesn't matter. It's the same combination of 5 people, no difference. But say I was doing something different and it was picking out 5 people who were going to get, the first one was going to win $100, then $80, then $60, then 40, then 20. It wouldn't matter what order. The first person would be the winner, the first prize. The second person would win a second prize. If the order matters, and it'll be clear in the question, hopefully, if the order matters, it's called a permutation, okay? And each different order is another permutation. Like horses winning a race. Does the order matter at which the horses cross the line? Well, to a lot of people it does. First, second, third. But if it was me buying horses for a property, then I wouldn't care what order I bought them in. I've just got a group of horses. So, permutations and combinations. And examples, just to go back to letters, not real life examples, just choose 3 of the letters from A, B, C. Well, if I've just got, like imagine A, B, C written on a bit of cardboard, choose 3 of the letters. In terms of permutations, if the order matters, that means A, B, C and A, C, B are different. Clearly, if the order matters, they're 2 different things. And I think of any other permutations. That's all. If I start with the A, B, C and A, C, B is all I got. What if I start with the B? An AC and a CA. They're different. What if I start with a C? I'd have an AB or a CBA. What about combinations? If I've got the letters A, B, C and I have to pick all of A, B and C, how many different combinations are there of the letters A, B, C? Just the one. If the order doesn't matter, then A, B, C, B, A, C. That's a team with Andy, Bo and Chris in it. I don't care about the order. It's the same combo of people. Okay, so we are not going to have to come up with all these things because these are going to get huge at times. The calculator's going to have a key for it soon. Once we've got the concept of what's a permutation, order matters, what's a combination, doesn't matter. What if it was only 2 of the letters from A, B, C? Well, what could I choose? I could get an AB or a B or an AC, sorry, did it that way. They're different. A BA is different to an AB in permutations. A BC, a CA, a CB. It's like we're talking about forming words in spelling. The order matters, it changes words. What about combinations? AB, yep, but BA is not a different combo. It's the same letters, it's just a different order. AC is the same as CA, BC is the same as CB. So in that case, I've got 6 permutations and 3 combinations. Okay, if order doesn't matter, I get less varieties of them. Okay. So, a permutation is ordered. We'll look at the permutations. Think P for position. It's going to be a P key on the calculator soon. So we definitely want to lock in permutation goes with P. And this was a student said it once. And I thought, actually, that's really good. If their position matters, it's a P question. Okay? If their position doesn't matter, it's just a combination. 6 friends sit at the front row of the theatre. How many possible seating arrangements are there? As soon as it says seating arrangements, the seating arrangement is different if 2 people swap or not. Okay? It changes. So if we're talking about arrangements on a seat, then putting the people with names A, B, C, D, E, F, G in order is different to putting B, A, C, D, E, F, G in order. So there's my options again. I've got 6 seats. I've got 6 different people that I could put in the first seat. There's no repetition here. How do I know that? Because good luck putting that one person on more than one seat. Okay, this is 6 people, 6 seats. So I've got 6 options of who I could pick for the first seat. I've only got 5 people left standing for the second, and then 4, then 3, then 2, then 1. Sure, the question didn't say no replacement, but our logic will get us through and say, that's got to be the case. If I times all of them, then that's my answer. There are 720 different ways to put 6 people on 6 seats. So when an object is arranged in order, each one of those different arrangements is just got a permutation. We say, well, how many permutations are there? 720. Same as saying how many ways are there. Again, the technicality, a lot of you will have seen this before, but back on that page, when I said 6 by 5 by 4 by 3 by 2 by 1, there's another button on the calculator that helps us. That is exactly the same as saying 6 factorial. In maths, an exclamation mark means factorial, and it's just a shortcut. Okay, 10 factorial just means 10 by 9 by 8 by 7, blah, 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 by 1. That's all that's saying there. Whatever this number is, if it's 16 factorial, what the calculator does is says, well, that's 16 times 16 minus 1 times 16 minus 2, and so on, all the way down to number 1. So there's a button, or your calculators will have, n factorial just means that number times by each one lesser than it, all the way to 1. So that just speeds things up for me. 5 different books will be arranged on a shelf, the number of permutations is 5 factorial. It's the same question as 6 people being sat on 6 seats, 5 people in order on a shelf, 5 books. I've got 5 options for the first spot, 4 options, 3 options. Again, I can't put one book in 2 places. It's definitely a factorial question. How many ways can 4 people be arranged in a line? Again, the first option, no. I can't, once I've filled the first spot, I don't have 4 options for the second. It's not Amy or Billy or Chris or Dan, it's not B, it's all C. Otherwise known as 4 factorial. Now this one looks a bit nasty, and we come back to it. We'll introduce the calculator in a sec. But firstly, manually, if someone asks me this question, Amy, Billy, Chris and Dan are playing musical chairs, and there are 3 chairs left, in how many different ways can the chairs be filled? So if there's only 3 chairs left, who could get a seat? Maybe Amy, Billy and Chris get to sit down. Maybe Amy, Billy, Dan, maybe Amy, Chris, Dan, Billy, Chris, Dan. But within each range, like Amy, Billy, Chris, if there's 3 seats, it could be Amy, Billy, Chris, Amy, Chris, Billy, Chris, Amy, Billy, Chris, Billy, Amy, Chris, and Billy, Chris, Amy. There are 3 by 2 by 1 ways that 3 people can sit on that one chair. Again, this is the long way, not the way we're doing it. Nice button coming up. There are 3 factorial ways those 3 people can sit in the seats, and there and there. So how many ways in total that could happen? Or, hence the plus, that could happen, or that, or that. So it's 4 by 3 factorial, which is 24. Yuck, horrible way to do it. What's the nice way then? That formula is what's in the calculator. We're not using that formula and put that formula on a resource sheet. We're never going to use it manually. But that formula is a formula that tells you how many ways, how many permutations there are for a situation. NPR is a number of permutations we can make when selecting R objects from a total of n different objects. So if there are 20 different things I want to select and I only want to select 3 of them, this will tell me how many different permutations there are of 3 things from 20. If I want to select 2 items from 5 items, I've got 5, there's 5 books there, but I only want to carry 2. How many different permutations are there of 2 books? Could I get book A and B, or A and C, or B then A, all of that? This formula will do it for me. If I did it manually, I'd say, well, there's 5 different ways I could get the first book, and 4 different ways I could get the second book, so my answer is 20. This is just showing what the formula does. The formula says, well, put the 5 factorial on top and put n minus r factorial on the bottom, and this is just proof that, and again, this is Neil watching, nerd hat, that's how the formula works. It works it out for us. Let's look at this one. We already worked it out to be 24. What's the nice way of doing it? Well, first way is, how many ways can the first seat be filled? There are 4 people. Okay. Second chair, 3 people. 24 ways. And the formula, which I don't think I've got on here, this is where we're heading to. 4p3, what does that mean? It means we've got 4 to choose from. Amy, Billy, Christine, 4 people to choose from. And how many are we choosing? Choose 3. I've only got 3 seats. So 4p3 says how many different permutations can I get of 3 people from 4? That's all we'll put in the cap, 4p3. And 4p3 is 24. Much nicer than every other way. Let's look at a few others. Oh, first look just the calculator. If I was putting 5p2, depends what calc you've got, but you'll see it on there somewhere, whether you'll need shift in that button or whether you've got 2 separate buttons. NPR and NCR will be on your calculator. That NPR, we'll look at the NCR later. But to do this, I'll just go 5, then the NPR button, then 2, and then equals, done. So in this case, 5p2 is 20. What does that mean in real life? It means if I've got 5 things, and I'm only going to choose 2 of them, there are 20 different ways, 20 different permutations I can get of choosing 2 things from 5. This speeds up what we did before. Before, when we were only picking 2 letters from A, B, C, we did this manually. We don't have to do this manually. If I've got 3 letters, and I only want to choose 2 of them, and know how many permutations, that's 3p2. Yep. So again, I don't have to write them out manually. I just have to use 3p2 as 6. If there's room for only 3 books on a shelf, in how many ways can 3 books out of a possible 5 books be arranged in order? Well, as soon as there's arranged in order, I know the different permutations that order matters. All I've got to look at is there's 5 options, and I'm only getting 3 of them. That's it, 5p3. Now, I'll also note that I can go to the calculator with 5p3, I've probably got it there at 60. Even the answer 5p3 is fine. Throughout this course, if you answer a question, just write 5p3 without going to the calc. Yeah, you're right. A lot of the multiple choice questions will just say that form. Because all we want you to see is that that is the answer to how many different ways can I get 3 things from 5 things. Just to look at if that still makes common sense. Well, if I've got only 3 books to put on the shelf and I've got 5, I've got 5 options of how to fill the first spot. I've got 4 options for how to fill the second, and 3 for how to fill the third. 5 fills a 20 by 3. Just proves that it works. So you can still do the boxes if you want, but 5p3, it's pretty quick. Again, this question, if there are 10 competitors in a race, in how many ways can the first 3 places be filled? I could go through manually and say, if it's person A, B, and C, it could be A, then B, then C, A, then C, then B, B, then A, then blah, blah, blah. And I've got all of these other letters as well. What's the quickest way? 10, P2. Or P3. How many ways can the first 3 places be filled? That's it. There are 720 ways to do it. I'm glad I stopped doing it manually. But that's just saying how many ways can I get 3 things from 10 things, and the order matters. Again, I admit I could do it manually. How many options are there for first place in the race? 10 options. Once that horse has gone through, or person, whatever's in this race, there's 9 options, then 8 options. 10 by 9 is 90, by 8 is 720. So manually, or your P formula. The number of ways electing a president and a vice president. That's meant to again be saying that the order matters. Person A being president and person B being vice president is different to person B being president, person A being vice president. So the order matters. I've only got 10 people. I'm picking 2 of them. My answer is 10p2. 90 different ways to do it. I could also think there were 10 ways to pick the first spot and 9 ways to pick the second spot. Yep, 90 ways. Okay. This next bit on combinations is exactly the same as what we just did. It's just the C key, and it's for cases where the order doesn't matter. It's not a president and a vice president. It's just 2 people on a team. It's just how many ones have I got to pick from, how many am I going to pick, and combinations is when the order doesn't matter. Again, its formula is a little bit different. We don't go into the formula. And on the calculator, it's wherever it is on your calc. It's just the NCR button, not the NPR button. In this case, NCR means I've got 7 things to choose from. I'm choosing 4. There are 35 different combinations I can make. Maybe it was A, B, C, D, E, F, G. There's 7 letters. I'm only going to choose 3. How many different combinations of letters can I make? 35. If I care about the order of the letters, it'd be 7P4. 7P4 would be much more. Where's mine? 7P4, 840. So if I care about the order, there's 840 different things I can get. If I don't care about the order, there's only 35. So from before we did this, choose only 2 of the letters from A, B, C. We'd already worked out 3P2 as 6. But if I don't care about permutations, only want combinations, that must be 3C2. Choose 2 letters from the 3, and there's only 3 combos. That's it. 6 permutations, 3 combos. Not manual, just using my formulas. Example here, 6 friends plan to play tennis. How many different doubles teams of 2 players are possible? It's interesting to see the word team. It's saying, look, they're all equal on the team. I don't care who got picked first. You're a team of 2 people. It's not captain, vice-captain, you're just a team. I don't care whether you stand to the left and you stand to the right. You're just 2 people and your order doesn't matter to me. So overall, all I'm doing is choosing 2 people from 6 and only care about combination. My answer is already that. 6E2. How many combinations of 2 people can I get from 6 friends? Choosing Amy and Billy is the same to me as choosing Billy and Amy. It's the same combo. So 6E2. Just to visualize that, the possible permutations of 2 players, if the order mattered, would be 30. But note if we did that and looked at all the combos, I could make all of those combos. And that, this is a list of all the permutations that could happen. But note that there's almost 30. They've got 6 by 5. But AB and BA, they're the same players. So AB and BA, so in other words, get rid of BA. AC is there, get rid of CA. AD is there, get rid of DA. That's why the whole number halves. I've only got half the possible number of combinations of permutations, because every permutation has another one which is the exact same, just the other order. Again, we don't need to. We answered it there. This one also has got an example, but straight for the jugular. 3 photos are to be selected from 5. Already, I know the answer is 5 something 3, because there's 5 things and I'm choosing 3 of them. The only thing I've got to work out is, do you care about permutations or combinations? This one's very nice. It says how many combinations of 3 photos are possible. Clearly, combinations means combinations. So we're not saying put them in order. I could do that. We're not saying order matters. It actually said combinations. 5C3. And 5C3, there are 10 combinations. Again, let's look at, well, where does that come from? If the photos were A, B, C, D, E, then there's all the different permutations. So it's a lot of permutations. But ABC, BAC, CAB, ACB, BCA, and CBA, there are 6 permutations that are all the one combination. Okay? All of them are just an ABC combination. That's going to happen again. All of those 6 are the same combination, different permutations but the same combination. Those 6, same again. Those 6. So for every single combination, it's got 6 times as many permutations. And so on and so on. They're all grouped in 6. So in this case, combinations of 3 from 5 was the total number of permutations. 60 divided by 6 is 10. But hopefully you agree with me. That's nice. Our hard bit is P or C. That's it. 3 students are to be selected from 10 students to form a debating team. How many combinations of 3 students are possible? Okay. Well, if 3 coming from 10, there's my 10. I'm only choosing 3. How many combinations? Again, no boggle. How many combinations? It's a C question. I'm choosing 3. from 10. And 10C3, I'll finalise with the answer there. 10C3, 120. Yep. Note here, shall wait, the note's coming up. How many committees of 3 people can be formed from 7 people? That's also meant to imply combinations. A committee isn't ordered, it's just a group of people. So combinations, the word group, no order, the word team, no order, committee, no order. All of these things are implying just combinations. 3 people formed from 7. 7C3, what's that one? Oops. 7C3, 35. 35 different committees will have unique combinations of 3 from 7. How many groups of 4 books can be selected from a shelf containing 10 books? Again, a group of 4 books. It's like if I borrowed 4 books from a library. It's been a long time. Do I care what order I put them over the counter? No. There's no order here that matters. A selection of 4 books from 10 books. Selecting A, B, C and D bookwise is the same to me as selecting A, D, C and B. I don't care the order. It's a combo. 10, I'm choosing 4. 10, C4, 210 different ways. Different combinations of 4 from 10. Okay, we've got an OR. This one is like the menu one before. I had dessert, or what was it, entree, main and dessert. I said, okay, I only want to choose 2 of them. So I've got to think of the different scenarios. I'm either going to get 4 books or 5 books or 6 books. They're all mutually exclusive events. One of these things will happen. So I'm going to get 4, or I'll get 5, or I'll get 6. Now I already know that the number of ways I can get 4 books from 10 is 10C4. If I chose instead to get 5, well that'd be 10C5. And if I chose to get 6 books, that would be 10C6. I only care about the combos. What do I do with ORs? They're just pluses for mutually exclusive things. That is a number of ways it could happen, or that could happen, or that. It's the same as before when I looked at, I could get entree and main, or main and dessert, or entree and dessert. 3 different mutually exclusive scenarios, and I just worked out the number of ways I could do each one and added them. So there's my answer again. That answer would be perfect, just going 10C4 plus 10C5 plus 10C6. But to go complete with it, 10C4 has got 10 different ways. Plus 10C5 has got 252. And we should see a symmetry here, 10C6 back to 210. We don't need to go into that, why there's symmetry there. It's all up, I can see them, 672. Different combos of 4 or 5 or 6. Again, confirmation, OR is just a plus. So, cards. Don't have a lot of card stuff in this week's lecture, but still, if you're getting dealt a hand of cards, and I know we're not all card players and not requiring you to be, if I got dealt 5 cards, what happens in playing cards is you then put them in what order you want. If I've got 4 aces, I don't care what order you gave it to me in, okay? I just care that I've got 4 aces and maybe a king, okay? Order doesn't matter. The hand of cards, it does not matter the order you got given them. You just have a hand of cards. So lock in. Cards are combinations. So, but again, cards are a good way to ask these questions. If I'm going to get a hand of 5 cards dealt for a regular pack of 52 cards, in how many different hands are there 4 queens? So again, it's not what's the probability of this happening? It's just saying how many different ways can this happen? Well, if I'm going to get a queen, a queen, a queen, a queen, that's all 4 queens that are in the pack. We know there's only 4. What else must happen? another card. Can I get 5 queens? There aren't 5 queens. So what it's asking is how many ways can I get 4 queens out of a pack, and how many ways can I get another card? Well, how many ways can I get 4 queens out of a pack? Anyone think of, and like only combination matters, so it could be the queen of hearts, queen of diamonds, queen of clubs, queen of spades. Do I care about the order? It's just 4 queens. There's only one way for that to happen. Okay? The one way you can get 4 queens from a pack of cards is that. Just get 4 queens. I could say, look, this is a combination question. I'm selecting 4 from 4. 4C4 is the number 1. Use whatever you want, doesn't matter. As long as the logic holds that. How many queens are in the pack? 4. How many are you selecting? 4. Do you care about the permutations or combinations? Just combination. 4C4. How many ways can I get 4 things from 4? 1. Again, it's the same as 4 people named A, B, C, and D. How many different combinations can I make of those 4 people if I'm picking all 4 people? Just 1. Okay? And that is a team with all 4 people. How many options have I got for the one remaining card? 48. So again, I could have answered this and said, look, there's only one way to do this, and then there's 48 ways to do this. My answer is 48. And my answer is 48. But let's think in terms of C notation, what am I saying? I'm saying now you've got to choose how many cards? Just 1. From how many cards? 48. They're both the same answers. 4C4 is the number 1. 48C1 is the number 48. There are only 48 ways you can do this. And I could list them. I won't. But it's those 4 queens and the 2 of spades. Those 4 queens and the 3 of spades. And I could go every single one of those 48 cards, and there's my 48 different options. So I'm going to stick with, I mean, this is cool, but I'm going to stick with this sort of notation because it's very tidy. And sometimes the answers are just left in that in multiple choice. And if it's written like that, you can see what's happened. I've chosen 4 things from 4 and 1 from 48. Yep, that's exactly what I'm trying to do. Okay, I've already gone through that. So, as an example, in a hand of 5 cards dealt from a regular pack of 52, in how many different hands are there only spades? So I'm choosing 5 cards, lock that in. I'm only choosing spades. How many spades are in a pack? Yeah, there's 13. It hasn't even thrown in any P options because cards are C options. It's definitely B. There are 13 spades and I want to choose 5 of them. I don't need to count the rest of the 39 cards. That question just said, how many ways can this happen? How many ways can I choose 5 spades from 13 spades? 13C5. That's it. Don't overthink these. That would be the issue. Think, no, I'm picking them out of 52. No, you're not. It only asked you about the spades. Burn the other cards. There are 13 cards, you pick at 5 of them. What about this one? In how many different hands are there exactly 2 aces? Not at least, not at most. Exactly 2 aces. So initially I'm picturing, I'm getting 2 aces. I'm not saying they're red, just the pen's red. That's going to happen. And if there's exactly 2 aces, well, I need 3 more cards. How many ways can I pick 2 aces out of a pack? Again, the C's are correct. How many aces are in the pack? There are 4. And I'm only choosing 2. So the beginning of these are all correct. 4C2, 4 aces in the pack, choose 2 of them. Okay? And I want 3 more. The decision is, I know I'm choosing 3. From how many? So my options there, it can't be from 52, can it? Because I've already pulled 2 cards out. Is it out of 48 or out of 50? Why am I looking at 48? Why not 50? I've only taken 2 cards out. What is the issue with me writing 50 there? That word. If we want exactly 2 aces, is it okay to get another? Okay, if I want exactly 2 aces, that means no more. Just give me exactly 2. How many cards are left that aren't aces? 48. So I'm not saying now choose 3 more for the remaining 50 because then I could get more aces. No, it's cut and dry. I want to pick 2 from the 4 aces. I want to pick 3 from the non-aces. Okay? 2 from 4, 3 from 48. That's the one I want. And that's the subtle little things that these questions come down to. They're just saying, you said exactly, I don't want more. Let's put a break in there. Yeah, back soon.
You can read that.
That's it, yeah.
That one. I like explain it how I thought, but I'm not sure if that's the right way. I got the same answer.
That's all. Where's the 120 from? Oh, that was the total of the thing.
Yeah.
Oh, yeah, okay. So 50% is an 8, and 90% is 4. Yeah, you know, I get it.
Yeah,
Yeah,
okay.
yeah.
How many of the quizzes count?
8.
How many do you
11.
11. Okay, so if you miss one, you don't necessarily have to say it.
It won't even count. You can sit if you want, but it won't even be so, but they go up in Blackboard, like if you want to check what the quiz was.
It was just last week, so I've been interested.
Oh, okay. So you could you can document and do it if you want. It's your call.
I didn't really get any time to like study for
Okay.
it.
Well, at the end of this week, I'll post a version in Quiz Mark Redemption, which is a version with the answers there, so you can just do it just to see what was in it.
Okay.
Just do it for practice and okay.
So when I look at Blackboard at the moment, does it make my mark get any different if it's not there?
No.
Okay. So it's only counting the ones.
No, Blackboard isn't smart. Blackboard is just a very close approximation. Blackboard isn't smart enough to be able to pick out the best one to know the count.
Okay.
So it'll just be a rough approximation. There will be an underestimate. Only one little bit, but under. Because it'll count only the quizzes. When in truth, we'll only pick a couple out. It doesn't pick any out.
So if you take the best ones, are they also ones with redeemed as well?
Yep.
Okay.
It's automatically when you look at that weighted average,
Yeah.
it's only picking. Blackboard's capable of that. You can pick the maximum.
Okay.
Yep.
And when it comes to the exam, how do we kind of know how much we need to pass the course?
Okay.
I think my weighted average is 81 something.
Okay. That means, say you continue with that till the end.
Yeah.
Call it 81. Then you've got 40 and a half so far. And then all you need in the final is let's call it 10 marks, which would be 20%.
I'm sure I'll,
You need 20%.
I'm sure I'll pass.
So,
say if you get like 70 or something in the final, how much does that drive your...
half the gap. You're at the moment about 80.
Yeah.
If you went up to 70,
Okay.
you'll be slap back in the middle of the 2 marks. Because the final's worth half and the progression's worth half. So
I'm trying to aim for that 85.
you're
That's my
capable
aim.
of that and more in the final. Because you'll do the revision paper.
Yeah, obviously.
Pick on any spots that were a difficulty and go, I've got this revision paper set for, your resource sheet gets set up while you're doing revision paper and all that, and just,
I feel like I hope I will. I think I struggled a little bit. I did come last Monday with that stuff, and because I was really sick, I probably and it didn't. They just kind of went back to online.
well, check it in because last week's lecture, very nice lecture.
Okay.
Basic probability.
Yeah, this week's okay.
Well, this is much worse than last week.
Okay.
And hopefully you'll see, hang on, all they're saying is all coming down to this PLC thing. That's it.
Yeah.
The rest of it's obvious. How many from how many? Well, that's obvious. PLC.
Yeah.
Yeah.
I came on Monday,
Yeah.
and that was it last week.
Okay.
And then on Wednesday, I admitted and I went home on Saturday.
So what you did it?
I had a swollen larynx,
Okay.
trachea, and esophagus.
From
I had like a stomach bug on Monday,
Okay.
and then I had reflux as well, and then all my slipped out, and then I got all these infections. And because that is so close to my heart, I'm hitting like 150 beats a minute, so I was like going into that stress.
You good now?
So there you go.
Okay, well, hopefully that's out of the system. You don't need that.
I still feel pretty off, but
Yeah.
catching up on the week of uni is really hard on me, so I was like, I have to do it. But yeah, that was a bit of a nightmare.
Yeah, sounds it.
I'm out now.
Yeah, well, onwards and
Between
upwards.
two different hospitals, especially. I'm just going to get a endoscopy, so like the camera down your throat.
Okay.
But that'll wait till after the test.
When you're awake or not when you're awake?
I think just semi-awake. Like you have an anesthetic, but only a weekish.
Okay.
I know, it makes me really nervous.
Not, how soon are they talking about going?
Well, they want us to do it next week, and I told them that it's really a good time for uni and exams and stuff. So they're going to try and schedule it for the end of November.
Nice. Okay. Yeah, absolutely.
It is kind of urgent because it's not obviously.
Well, yeah, they probably want to look at it, yeah.
They do want to. They're going to look this week. Like at first it was this week and then it was next week.
See what you've got to do, maybe. Anyway, you'll sort it.
I'm sure I'll survive.
Yeah. Aim for that.
Thank you.
Okay. Alright, moving on. You can see that most of the lecture's finished. We're now just dealing with iterations of the same sort of question. So the harder ones. As long as we've locked in the difference between P and C and the setup of these questions, now the last, not that many slides, is just what about the twists? And here's one of them. So we've got the hand of 5 cards coming again, regular pack. That's never going to vary. We're not going to chuck a joker into one just to put you off. How many different hands are there? At most 1 ace. Okay. So here I've got to look at what sort of scenarios I've got. And it's still like last week. Sometimes the quick way is going to be find all the answers to it. Sometimes it's going to be find the opposite. Let's just check first. At most 1 ace. That means an ace but no more. So I've got 5 cards coming to me and saying, yeah, you can have an ace, but that's the maximum. So does no aces satisfy this? No aces will be okay. Now if you want at most 1, that means, I think of at most 1 as 1 or less. So 0 aces is fine. So to me, I'm looking at only 2 ways this can happen. At most 1 ace is equal to, yes, I could get 1 ace, or no aces at all. They both satisfy at most 1 ace. I'm still getting 5 cards. So in one scenario, I've got an ace and then 4 other options. In the other one, I've just got 5 other options. How many ways can I get 1 ace from a pack of cards if I use my C notation? 1. And how many am I choosing from? So the first thing I'm doing in my 1 ace scenario is I'm choosing 1 ace from 4 aces. Admittedly, that is just the number 4, because how many ways can I get an ace from a pack of cards? 4 ways. Ace of hearts, ace of diamonds, ace of clubs, ace of spades. That's the same as 4C1. And I want to do something else. Clearly, I want to choose 4 more cards. How many from? 48. Exactly right. I don't want to risk getting more aces, because here's my scenario, exactly 1 ace. So how many non-aces are there left? There are 48 non-aces. There's 51 cards, I don't care. I want to choose 1 card from the aces and 4 cards from the non-aces. That's it. Or, get 5 cards from the non-aces. What would that be? It's not even a 2-step thing. Get 5 cards from the non-aces. How many non-aces are there? That's it. That's it for the second bit. If I want to get a hand of 5 cards dealt that aren't aces, I'm just saying, all right, choose 5 cards from the 48 non-aces. Again, we can calculate that. The 4C1 I was saying was just the number 4. A 48C4 equals 194,580. Okay, a lot of ways to do that. 48C5 is 1712304. So all up I've got that number plus 4 by 194,580 equals 2.5 million ways. Close enough. Okay, lots of combos in cards, clearly. But at most 1 ace, our hard work, I reckon, there was just going 1 is okay, 0 is okay, nothing else. Okay. And again, if this was a written question and you left the answer there, correct, we know you can use a calculator. We want to see this. Okay, now of subtle change. In how many different hands are there at least one red card? So again, I want to go through and think, well, how many scenarios is that? To have at least one red card. That's saying one red is okay. Otherwise, I want more. So that could be one red and 4 black. That satisfies. 2 red and 3 black. 3 red and 2 black. 4 red and 1 black. 5 red and 0 black. You can see, ooh, this one's horrible. Yes, I could work all of them out and add them up. But what's quicker? What's the opposite of everything I've written? There's only one option left, and that is no reds and 5 black. This is like last week. If we said, what's the probability of this? I could add up all these 7 options or just say 1 minus that. It's just in this week, it's not probability. This week, it's number of ways it can happen. First, I'll ask you, how many different, without any restriction, if you've got 52 cards, you're going to pull out 5 at random, how many different combinations can you have of any 5 cards out of 52? 52 C5. That's no restrictions. That's the total number of cards I've got that I could deal 5 cards out of a pack. So instead of working out that answer and 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 adding them all up, I could just say it's the total number of options minus that. Now both ways is totally fine. Okay? We can do it both ways. Clearly I'm implying that this way on the left is going to be quicker, but it's not a have to. Let's look at both ways. Firstly, let's look at the way I reckon it's quicker, because I'm saying at least one red card is the exact opposite of no reds at all. What's the probability of getting 5 black cards out of a pack of cards? Not probability, sorry. How many permutations? All I want to do is get a hand of 5 cards from the black cards. How many black cards are there? Already there's the answer. The answer to this question is 52C5 minus 26C5. What that means is the total number of ways minus all black. The other way I could have done it is, okay, I want 1 red card and 4 black cards. All right, 1 red card is from the 26 red cards, pull out 1. And then pull out from the 26 black cards, get 4. Plus, the second option is get 2 red cards, 26C2, times 3 black cards. Oops. Plus, the next one is 3 from the reds times 2 from the blacks. It's not that bad. Once you see the progression, that all I'm doing is I keep taking certain ones from the 26 reds, certain ones from the 26 blacks. That's the third option, plus the fourth option is 26C4, 26C1 plus 26C5. It's going to give me the same answer. I've already got it written out down here. That, plus that, plus that, plus that. It gives all of that, which is approximately 2.5 million. Well, it's exactly the same. 52C5 minus 26C5 is the same. Total number of ways minus the only way you don't want to count equals the sum of all the ways you do want to count. We've got more like that coming up. Okay, more once these fine twists. A committee of 5 people, as soon as I read that, I'm not in permutation land. I don't care. It's a committee, it's a team, it's a group. I just want to know combinations. 5 people is to be chosen from a group of 7 men and 4 women. How many different committees are possible? Well, this first question doesn't care about men or women. It just says how many different committees are possible. How many people have I got here to play with? Yep, I've got all 7 and the 4. I've got myself 11 people to choose from. How many do I want to choose? Committee of 5. That's it. The answer to the first one is 11C5. I chose C because it's just combinations mattered. I've got 11 people to choose from and I'm choosing 5. 11C5 is the total amount of ways I can do it. Don't worry about the calc, 11C5 will do. How many different committees are possible if a particular woman, Diane, must be included? So someone's come up and said, look, one of those 4 women, Diane, you've got to put her in the team. Okay, if she's already in the team, how many people have I got left to pick from? 10. How many people do I need to pick? 4. If one woman is already placed on a committee and that's locked in, then I've only got 10 people left, not 11, and I only need to choose 4 more. 10C4. So one person is forced onto the committee. There's only one way to do that, it's done. The total number of combinations is choose 4 from the remaining 10. What if 2 people were locked in place? These 2 people are in the committee, that's it. Think of how many you've got left to choose from and how many you want to choose. Anyone's the same trend? 9C3. Now 2 people are locked in at the 11, I've only got 9 to choose from, and I've already picked 2 people on the committee. Okay, that followed the trend. 11C5, 10C4, 9C3. All perfect. Solely the questions, but hopefully if you do it, even write out, 8-person A, B, C, D, E, cross that one out, look at how many options you've got. Another one, personalised one. Taylor, Silver, Tommy, Syed, Tamara, Blossom, Em and Joe are all being considered for a team of 3 people to represent New Step 2017. How many different teams are possible if everyone's available? Okay, now how many people have I got? 1, 8, okay. So 8 people available, I'm picking 3. Is this a P or a C situation? C. Its position doesn't matter, this is just a team, a group, equal. We want equals in here. It's a C question. So if everyone's available, it's 8C3. Choose 3 from a group of 8 people, and we're done. Emma's ruled out. Sorry if you hear him. She's ruled out. She's cooked. Can't be in the committee. How many different ways can we fill the rest? 7, C, still 3. So it's not the same as last time. 7C went down to 2. I've got 7 people to pick from. So M's a sicko. And 2. 3. Listen to what you're saying, David. I've still got to pick 3 people, but they've got to come from only 7, not 8. Tommy must be included. You've got to have him. How many are you picking from? How many spots left? 2 spots left, and you're not picking from the full group of 8. Tommy's been put in. There's 7 people left to decide about, and I only need 2 people. Yep. Syed and Taylor must be included. Or Taylor anyway. What do you reckon, Syed? What's the answer to this one? 2 people forced onto the committee. Head up, come on. 6C1 sounds good. Of the 8 people, 2 have already had decisions made about it. There's only 6 people left from the 8 to pick from, and 2 people are already in the committee, so it's 6C1. 6 people left, choose one of them. Yep. If Joe must be included and Tamara is unavailable. So Tamara's just ruled out, and Joe must be included. So neither Joe nor Tamara are a part of the debate now. So I've got only 6 people to decide from. How many people do I want to choose? 2. Only 1 was forced onto the team, 1 was out. So it's a 6C2. 6 people left to pick from. I still need 2 people because only 1's been forced on the committee. This is, oh my God, this is a blatant sort of question. This is where I've been heading in the lecture. And I really don't think it's full of traps. Let's just slow down and read it properly. That's it. And it becomes fairly obvious. How many have I got to pick from? How many do I need to pick? That's permutations and combinations. Okay. More. Blossom refuses to be in a team with Silver. Okay. This one's the extra twist. Firstly, let's do what I'll call the long way. It's not that bad anyway. Blossom and Silver are two people, and we can't put them in the team together. What ways can we satisfy this question? Like we could have, here's Blossom, here's Silver. Would you agree that Blossom could be in the team and Silver could be out of the team? That satisfies it. What else could happen? Other way? Blossom out but put Silver in? Have we covered all possibilities that stop them from being on the committee together? They could both be out. That's not putting them on the committee together. They're the three ones we want. What's the only remaining option anyway? That they were both in. Oh, sorry, I should have said. That doesn't satisfy. There's only four things that can happen. They're both in, they're both out, one in, one out, the other in, one other out. There's only four different outcomes here, and three of them satisfy the question. So let's just go for adding up those three options. If Blossom is in and Silver is out, how many people are left to pick from? 6. And how many people do I want to choose for the remaining committee? 2. What about the other way around? It's exactly the same thing. The other way around is still 6 people to pick from, choose 2 of them. What if they're both ruled out? How many can I pick from? How many do I want? There's answer number 1. Just adding them up. 6C2 plus 6C2 plus 6C3 is the answer. There's an or. There's nothing wrong with that. I mean, I said it was a slow way, long way. It's not really that harsh, is it? The other way is to say, look, it's the total number of possibilities minus the only one I don't want. The total number of possibilities is the first question I answered, which is there's 8 people, choose 3 of them. If they were both forced onto the committee, how many ways can that happen? Think of how many I've got left to choose from and how many do I want if they're both forced on the committee. I know they don't look like it, but they're the same answers. Okay? If we stick it in the calculator, I've got 6C2 plus 6C2 plus 6C3 equals 50 ways. 8C3 was the first thing we had, which was 56, minus 6C1 is 6. But if that makes sense, you've nailed the hardest part of all of this, which is just satisfying the question, work out how many ways it can happen, and either going forwards or the total and going backwards. Same thing. No different. Except for, different. Note here that I was going to bring up before, factorial notation. You can see we're pretty much left it. You can still do these things manually at times, but it's only for permutations. I just want to lock in because I just remember one year, a lot of people just want to do this factorially. If I was talking about those 7 people on 7, or let's go 3 people on 3 seats, that's 3 in the first seat, 2 in the second seat, 1. If you're doing that factorial notation is only for permutation questions. If you've got combination questions, the factorial doesn't work. I avoid it anyway. I'm a big fan of just using the P and C notation. To me, it's the quickest, easiest, most understandable way to do it. But if you're ever using this factorial stuff, note it's only for permutations. So, we've still got a few more, and this last chapter being application of probability, it's a very subtle difference. All it means is some of them we're going to end up with a probability question. But that's understandable. It's a probability topic. And all we've worked out is quick ways to count up the number of ways things can happen. They just happen to be big numbers. But we still know that if you want to know the probability of something, tell me how many ways it can happen over how many ways overall things can happen. Yeah, sure, we can turn these into a probability. Let's check. How many 3-letter arrangements can be made from the word computer? My first question is thinking about arrangements of letters. Does the order matter or not? Like, is BAC different? Well, maybe not from those. Does COM different to CMO? They're different arrangements. They're arranged differently. Arrangements is a permutation question. How many different arrangements? The books on a shelf, how are they arranged? The people on a seat, how are they arranged? The order matters. Arrangement, definitely. So it's a permutation question, so I've locked in my P. And now I just want to say, how many am I picking from how many things? Well, I'm only picking 3 from 1, 2, 3, 4, 5, 6, 7, 8. So it's 8P3. I'm done already. I knew it was going to be 8 something 3. Notice there are different rules when you've got repetition of letters. We're not going there. We don't go into advanced probability. I'm picking 3 things from 8 and I care about the order. Done. What's the probability that one of the arrangements selected at random begins with M? Okay, we've got our first probability question. And there's 2 main ways to look at it. Firstly is the last week way. If I put the letters C-O-M-P-U-T-E-R on a bit of cardboard, each letter, and put them in a hat, what's the probability that I pick out an M first? 1 in 8. That is the answer. Okay? Last week still exists. If you're asking about the word starting with M, let's pretend I'm writing it in order. What's the chance that M comes first? 1 in 8, that's it. Well, let's just compare that to this method that says, okay, the total number of possibilities is this. So I'm saying that my denominator for this question is 8P3. In other words, 336. What's the probability that one of the arrangements selected at random begins with M? So if you're locking in the first letter is M, how many more letters have you got to pick? Only 2, because I'm picking 3. Out of how many? If M's already been put in, well, that's saying I've only got 7 letters left, and I've got to get 2 of them. So 7P2 over 8P3, which is, I think I've got it under here. We know it's 1 in 8, we already discussed that. But 7P2 over 8P3 would have been another way to say it. There's 7P2 ways, combinations of M being first, which is 42 ways. There are 336 in total. It's still an 8th. So I'm not saying every question we just go straight to P's and C's. If it's as simple as this one, an 8th is good. But it'll be very easy to miss that. Okay? It'll be very easy not to see that. Let's keep doing more. What if a student team is to be selected from 5 girls and 4 boys? Is a student team, a 2-person student team, a permutation or a combination? Team, combination, don't care about their position. From 5 girls and 4 boys, well, I'm just choosing 2 people from 9 people. So unless you've got other restrictions, it's 9C2. How many different selections are possible? Exactly it. Why have you stopped? 9C2 was 36. Yep, 9 people, choose 2, combination, done. Okay, what about some restrictions? How many of these selections have 2 boys? So it's not the probability, it's just how many selections. In how many ways can we select a 2-boy team from 5 girls and 4 boys? Well, the 5 girls aren't even part of this question. All that's really saying is you've got 4 boys, how many different ways can you choose 2 of them? It's 4C2. Okay, just because the question had girls in it, if I've got an individual question that only asks me about the boys, then the girls weren't part of this question. How many different ways, not probability, how many different ways can I select 2 from 4? 4C2, that's 6. Hence, what's the probability that both of the selected students are boys? Well, we've worked our way up to it. The probability that both the selected students are boys is the number of ways you can get 2 boys, 6, over the number of ways the committee could have been formed, 36. Not unusual for this sort of question. Good circle. Hence, in other words, use the info you've just had to work this out. 6 ways to answer the question, there's 36 ways in total. It's a 1 in 6 chance. Six on 36, done. Okay, another scenario, 5-student group from 9 girls and 7 boys. Okay, again, we're still just 5-student group, combination. How many different selections are possible containing, oh, here we go, exactly 2 boys. This is just like cards. The numbers are smaller. If you want exactly 2 boys on the committee, that means, okay, so I'm picking 2 boys from how many? From 7. There's part of my team formed. What else needs doing to complete this 5-student group? If it's exactly 2 boys, it must be 3 girls. Out of how many? 9. What do I put between these? Is it 2 boys or 3 girls? Or is it 2 boys and 3 girls? It's an and, it's a times. There's my answer. Exactly 2 boys is choose 2 from the 7. It must be exactly 3 girls, choose 3 from the 9. Same as the cards. It's like choosing some of the aces from the 4 and some of the non-aces from the 48. Same thing. 7C2 by 9C3, which ends up being 1764. Okay, gives another scenario. Oops, sorry, a bit quick. So exactly, it's nice when it says exactly. There's no variation to it, it's just straight in. In how many ways can the selection contain, okay, as soon as it says at most or at least or something, it makes things more complicated. But firstly is just the common sense approach, working out what situations satisfy at least 2 girls. At least 2 girls means 2 girls on the committee is acceptable, and so is more. So in other words, 2 girls, let's go this way. 2 girls, 3 boys is an acceptable makeup of the group. 3 girls and 2 boys must also be acceptable. 4 girls and 1 boy must be acceptable. 5 girls, 0 boys must be acceptable. So I still could do it the other way and say, look, there's only 2 other options, but let's just go forwards. Keep it simple. Hopefully you agree that they're the different ways to have at least 2 girls, is 2 or more. Yep, we've got all scenarios. So we're just going to add up some probabilities, or some possibilities, sorry. 2 girls, well that's selecting 2 from 9. 2 girls is 9C2. 3 boys from the 7, well that's 7C3. Notice I don't have to put the times in there, it's the same as algebra. If I write nothing in the middle, yeah, it's a times, okay? Whether you do or don't, it's your call. If that was 9C2, 7C3, the next one must be 9 choose 3 girls, 7 choose 2 boys. And already you can see, okay, one goes up, one goes down. That'll be a 9 choose 4, and that'll be a 7 choose 1. And this will be a 9 choose 5. Technically I don't have to write anything here, because this is a scenario that in how many ways is going to get 5 girls from 9 girls? 9C5. If you want to complete the pattern and you wrote 7 choose 0, it's not a problem. 7C0 is just the number 1. It's not wrong, you can write it if you want, just because it's just to complete the pattern. But whether you wrote the 7C0 there or not makes no difference, it's just the number 1. In how many ways can I choose do nothing? 1 way, do nothing. So the sum of all of them is our answer in this case. Again, the C notation will do. Alright. The last bit. Consider the arrangements of the word peanut. How many possible arrangements are there if there are no restrictions? Already I've seen possible arrangements of the letters in the word peanut, and I'm going permutation. Different arrangements mean different things. This is a permutation question. If there are no restrictions, it's a P question. 1, 2, 3, 4, 5, 6. And I'm choosing how many possible arrangements. So we're getting the whole 6P6. If we're getting the whole word and just rearranging it, it means I've got 6 letters, pick 6 of them. Okay, so that is 6P6, which is the same as 6 factorial, which I think is 720. 6P6, yep. But 6P6 will do. Permutation or combination, Well, we've already said that it's a permutation. So 6p6, or 6 factorial if you want to go that way. I'll just prefer with the p notation. The word begins with n. So this is like putting a committee member on. One position is locked. How many options have you got to choose from, and how many are you choosing? If it's already been locked in, it's going to start with n, there's 5 more letters to put in place. And we're going to pick off 5, yeah. So whether you write 5p5 or 5 factorial, they're the same answer. Okay, because there's 5 options, then 4, then 3, then 2, then 1. For me, 5p5. The word begins in A and ends with T. All right, if you lock in the A to the front and the T to the back, there's only 4 spots and 4 things to do with it. It's a 4p4. Pick 4 letters from 4 letters, okay, because these spots are taken. So we've got a definite trend there, 6p6, 5p5, 4p4. E immediately precedes A, means next to the left of, immediately before. So not just to the left of in total, but immediately to the left of. So if E immediately precedes A, that means that no matter what you come up with, you want to see an EA in there. Maybe the rest of the things go, was it P, E, A, N, U, T? Maybe it's like that. Maybe that's in there, maybe that's in there. I don't know where it is, but the E, it's like it's sticky tape to the A. Given that scenario, it's like I've tied them together. Cable ties, can't get away. How many things have I got to choose from, given that E and A have just come a thing? If I move EA as one thing, it's like EA is a thing, and so is the P, the N, the U, and the T. I've only got 5 things to rearrange now, because I've locked those 2 together. So if there's only 5 things to move in 5 different places, it's 5p5. I remember that being said at school, that you tie them together, they effectively make one item. I've only got 5 items and 5 spots. Yep. E's next to A is subtly different to the last one. Not maths-wise, just in words. What possibility has that opened that now I've just said next to instead of proceed? Could be the other way around. That's saying EA is acceptable and AE is acceptable. I just want them next to each other. So like part of the answer is I've got 5p5 ways of doing this. How many ways have I got if it was AE, not EA? Exactly the same thing. If I undid them, put them on either side, the other side, and taped them together again, I would have exactly the same thing I could do again. And what's an or? It's a plus. That could happen, or that could happen. 5p5 plus 5p5 is the answer. Or 2 times 5p5. Because if I've got it plus itself, it's the same as saying 2 of them. There are 2 different ways, and they both have the number of ways of doing it as 5p5 and 5p5. So 2 of them is the answer. And the last one, again, predictable sort of question. What's the probability that E is next to A? Well, we found out how many ways E is next to A. It's a probability, so it needs a denominator. And the denominator is always how many ways can you do it without restrictions? Just how many possible ways can you form anything here, which is that. So it's telling us that the number of ways E could be next to A is 2 by 5p5. True. Divided by the total number of ways this can be done. That's probability. There it is, 2 by 5p5 on 6p6. Basically it's answer V on answer I. Just same as that. And congrats and good luck, definitely. Remember, clinic's still going on every day. Revision paper will be up the Savo. Redemption's all still welcome. We'll have an amnesty. I'll put an announcement, say, still get your B's in. Your B redemptions. Thanks. I'll just turn this off. Yeah. Upside down. No, it's how many, it was the 4C2 on top, because that's how many ways you can satisfy the question. So with 4C2 goes on top, how many ways can you answer the question? The bottom is how many total ways things can happen with 9C2. So it's a 6 on 36. It's a 6. And 9C2 as well. That was 2 before. See ya. Yeah, that was 9. Yeah.
Thanks, mate.
No worries. 6 over 36. Cool. Welcome to it. Sorry?
It's been a pleasure.
It has been. Oh, you'll be back to drop-ins.
Yeah, thank you for your call. Apparently you can't renew your book. So alive.
Good.
Standing, I'll be on my name.
Can we get my redemptions here? Yeah. There's 1 and 2 there. Is that okay?
Yep. Cool.
Thank you.
Can I give you that?
Yep.
Sorry, it's really good for my back.
Okay. Let's see how this is.
Have you all just finished a class in this room, or have you just come specifically for this session?
Finished a class over at Inform.
Okay.
Yeah.
Yeah, just here for the session.
Yeah, okay, great.
Yeah, on this class I've got here. So
Okay, well that's good timing.
makes it easy.
Great. We'll just wait another 5 minutes or so. Still only 3-2, just in case there's a few late stragglers, which almost always is. Just out of interest, have you all seen the web page? Yes? What about this video? Have you just watched that while you've been here or seen it elsewhere? Okay. I reckon it's worthwhile watching. It's only 3 minutes. So I'm Jamie Ingram, program coordinator for the Ireland Northern Scholarship Program. For a chair, I feel a bit funny standing in front of this group. Is this someone's umbrella award? So, just out of interest, where have you guys heard about the scholarship program?
Through Open Foundation.
Okay. Through a lecturer talking about it, or
No,